Hi, let us talk about this problem. We are given a number n. We need to check whether this number n is a power of 2 or not. So 4 is a power of 2. It's 2 raised to the power 2. So output is yes. 6 is not a power of 2. The example powers of 2 are 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3 and so on, which have values as 1, 2, 4, 8, 16, 32 and so on. So if you are given these values, then you need to return output as true. Otherwise, you need to return the output as false. Now please pause this video and try to think of a solution to check whether a given number is a power of 2 or not. In our solutions, we may assume that n is a non-negative integer. It is either 0 or positive. So a simple idea, a naive idea to check whether a number is power of 2 or not is to repeatedly divide the given number by 2. At any point, if it becomes an odd number, then you say that this number is not a power of 2. And if it never becomes an odd number and finally becomes 1, then you say it's a power of 2. For example, 4. If you divide it by 2, you will get 2, which is an even number. If you divide 2 again by 2, you will get 1. So you get 1 at the end. If you get 1 without getting any other odd number in the middle, you say it's a power of 2. 6. If you divide it by 2, you will get 3. 3 is an odd number. So you did not get 1, but you got an odd number. So you say 6 is not a power of 2. Other examples, you have n equal to 16. You will divide it by 2, you will get 8. Divide by 2, you will get 4. Divide by 2, you will get 2. Divide by 2, you will get 1. So you never got any odd number. You got 1 at the end. So you say it's a power of 2. Right? So that's the idea we have implemented here. If n is 0, then we return false. Then this 0 is not a power of 2. Otherwise, we run a loop while n does not become equal to 1. And in this loop, what we are doing, we are dividing n by 2. And we are checking if at any point it becomes an odd number. If it becomes an odd number, we return false. So you keep on dividing n by 2. If it becomes 1, you come out of the loop and you return true. And if it becomes odd in the middle, you break out of the loop and break out of the function and you return false. This is not a power of 2. So in case of 6, you will break here, right? You will come here, you will first divide, you will check it's even, you will come here and you will make it 3. Then you will run this loop for n equal to 3 and you will come here and you will return false. For n equal to 4, you will come here, you will divide, you will make it 2. For n equal to 2, you will come here and you will divide, you will make n equal to 1. So n becomes 1, you come here and you return true. So this is a simple method. It mainly traverses through all the bits. Now, can you modify the solution? Can you optimize the solution to work in better time? A better solution than this is to use Bryan-Kernighan algorithm. An interesting fact about powers of 2 is they have only one bit set. For example, if you take binary representation of 4, it's 1, 0, 0, all the preceding zeros before it. So there is only one bit set. If you take 8 example, so this is binary representation of 4. If you take 8, this also has only one bit set. So you can use count set bit logic. You can count the set bits and if the count is 1, then you say it's a power of 2. You can count set bits using Bryan-Kernighan algorithm in theta of set bit count, which is 1. Right? So you can do it in theta one time. But there exists even a better solution. Please pause this video and try to write down only one line expression to check whether a number is power of 2 or not. Let us now talk about method 2. The idea is again based on this fact. If a number is a power of 2, then it will have only one set bit. Otherwise, it will have more than one set bits. If you leave the case of 0. In case of 0, all the bits are 0. In all other cases, if the number is a power of 2, it will have one set bit. Otherwise, it will have more than one set bits. So what you do is you unset the only set bit. And if your result becomes 0, then your number is power of 2. And if you unset a bit and if the resultant number has more set bits left, then your resultant number will not be 0. It will be some number greater than 0. Now, how do you unset a bit? You can always unset the rightmost bit of a number by doing bitwise AND of that number with n minus 1. If your number is n, if you do a bitwise AND of n with n minus 1, you will always unset the rightmost set bit. And if your resultant number becomes 0, then you return true, otherwise you return false. Let's see how does this work. Let's take a look at this example. Say n is 4. It will have only one set bit. How do you unset this bit? You compute n minus 1, which is 3. You get this number. So all the numbers after the set bit, which were 0, all the bits which were 0, they become now 1. So if you do bitwise AND of these two things, you will get all the zeros. So you get zeros, it means your number is 0, your resultant number is 0. And if your resultant number is 0, then your original number was a power of 2. It had only one set bit, which you unset after doing bitwise AND with n minus 1. Let's do the other example. When n is 6, and if you compute n minus 1, you get 5. And if you do bitwise AND of these two, only this particular bit is unset, but you have one more bit here, which is set. So you will have a resultant number which is not 0. Your resultant number is 4. So that is why you say it's not a power of 2, because the resultant number that I got is not 0. So what we have done in both the examples, we have unset the rightmost set bit. And if it was only the set bit, then we get the number 0. Here we unset the rightmost set bit. Since there are two set bits, you do not get 0 in the result. Right? You have still one bit set in the resultant. So that is why it's not a power of 2. So that's the idea. We return true if this result is 0, otherwise we return false. Here is one line expression for the same. We return true if n is not 0 and this expression is also 0. Right? If both the conditions are true, then we return true, otherwise we return false.